I'm in the basement IDF of one of my clients' buildings, and I wanted to show you the new troubleshooting kit from Profitap that includes the IOTA 10 core. So what we've got in here is we've got a number of tools that you will need to get in the path of the packets, capture those packets, and be able to analyze them. So let's take a look at what is in this kit of equipment. So if we start out, what we find is that this comes in a really nice travel case. So inside this box, when we open it up, the first thing we see is the IOTA 10 core. Now, this is a capture to disk appliance. So let's take a look at the interfaces that are available on this piece of equipment. So what we've got is we have two management ports. So this is where we can connect this to our network and we can remote into it. And that's one of the big advantages of the IOTA family of capture to disk tools, is that we can deploy those out there anywhere in the world. And if we have an internet connection to it, we can get in there and we can start analyzing that traffic. So these two management ports allow us to go in and connect to the network. Next to that, we have two copper capture ports. These have RJ45 connections on them, and they support 100/gig connections. So I can connect to 100 meg or I can connect to gig, and I can send data into these ports. So an excellent use of these is connecting them to a span port on one of my switches. So if I have an extra copper port, I can plug that in, I can route that traffic, well, I can span that traffic over here to one of these ports, and I can do a packet capture. And one of the really cool things with the IOTA 10 core is I can create separate capture sessions for each one of these different ports. And this allows me to segment that traffic out when I go in to do my analysis. From there, I have two gig/10 gig copper ports. So with these ports, I can connect up a copper 10 gig or a copper 1 gig link. So much like we've got with the 100/gig ports, we can take those off of a span port, we can bring data in here, we can start capturing. And then finally, we have our two SFP plus slots. Now these allow us to capture traffic at 10 gig. So we can connect up our fiber connections here, we can pump 10 gig traffic into this, and it's going to capture it. Now, one of the nice things with the core is the core will capture up to 20 gigabits per second, or about 10 million packets per second. So this allows us to bring that data in, write it to disk, do some analysis on it, and then have it there so we can go back in time and we can take a look at what's going on. So I can store a lot of traffic on here, and this gives me the ability to look way back in time as far as what's happened. So there's our IOTA core that allows us to go in and do our capture. Now, the other thing that we have up here on the top of this is the span booster. Now, the span booster is a pretty neat piece of equipment. The span booster allows us to bring traffic in from 8 different connections. Now, these can be 1 gig fiber connections. We could put a copper SFP in there if we want to. But in most cases, what I'm going to do is I'm going to put a fiber SFP in there that supports 8 1 gig connections. Now, what it does is it aggregates all of that traffic together into this output port. Now, that output port supports either 1 gig or 10 gig. So when it comes to doing my packet capture, if I'm down here in an IDF like this, I could put the span booster in here, and I could come out of each of my switches with a fiber gig connection, connected into the span booster, and then I could aggregate all that together and backhaul that back to the MDF to the IOTA 10 core. So this can be deployed out here in this wiring closet, and the core could be put in the MDF or somewhere else in the building. Now, what we're going to do is we're going to use this span booster to bring all of our fiber outputs together from our inline tap. So let's go ahead and take a look at that. So we're going to remove the top layer here. We're going to get down to the next layer of equipment. And here is our fiber tap. Now, this is a passive tap that allows us to passively tap into 4 1 gig connections. So for each one of these, I have an in and an out. So I come out of my patch panel into my switch, and this sits right in the middle. It does an optical split of the light. So the nice thing with this, there's no electronics. There's no power. We don't have a power plug on it. If something fails, which it can't because there's no power, this will continue to pass traffic. So it's just optically splitting the light in here. Now what it does is it sends the transmit for each fiber out this port right here. So now I've got one for one direction, one for the other direction. So what I'll do is I will connect this to my span booster. The span booster will aggregate all of these outputs together and send that off to my IOTA 10 core. Now, included in here, we have our SFPs. These are our 1 gig SFPs that are going to go into the span booster. And also, we have these fibers. Now, these fibers are kind of interesting because one of the challenges that we can run into when we're using a tap, let me get that out of there, is I have 2 outputs. And I need to make sure that those go into the receive ports on that span booster, the SFPs that are in the span booster. So what we find is that this is a Y cable. So we have this end, and this plugs into our output on our tap right here. So what we would do is we would plug this right into our tap right here. So now we have light coming into both of these fibers. Now, to make it easier to ensure that those are aligned to the right ports on our SFPs, what they've done is they've created this cable where the fiber from the tap passes through and comes in here to this A side right here, and the B side just dead ends right there. So all this is set up to do is make sure that your alignment is correct when you go in and connect this up to the span booster. So out here in the IDF, I put in my tap. I tap into my fiber connections. I use my Y cables to connect that tap over here to my span booster. So now I'm bringing all that traffic from this tap into the span booster, and I connect that span booster up to my IOTA 10 core, and I can go in and do my capturing. Now we also have some rack mount brackets in here. So if you want to rack mount the 10 core, you could do that. And we've got the power supplies. So the idea with this equipment is that you have all of the building blocks necessary in this one case to go out, tap in, and start monitoring traffic, writing it to disk, and then have the ability to go back in time and see where things may have gone haywire. Now, when we go through the deployment of these, there are different types of boosters out there. We've got a copper inline booster, and we'll look at where that fits in because that's fault tolerant. It passes PoE, so if I have some copper connections I want to tap into, that works really well, and it sends that traffic out at 10 gig, and I could use my second 10 gig port on my IOTA 10 core. So this is just kind of the beginning of what we can do with this. Now, what would be the best scenario? I deploy my tap ahead of time. When I'm building out my network, I tap those key connections that I want to be able to monitor. Then, when I come in with this equipment, I'm not having to break any fiber links. I'm just taking and connecting that span booster up to those outputs, routing that output back to my IOTA 10 core, and I'm capturing traffic. So I hope you found this useful as a way to see what's available in this troubleshooting kit that's based around the Profitap IOTA 10 core.